let's do some reviews for your exam 1. So your exam 1 will cover sections 2.5, 2.1 through 2.5, okay? Which is what? Derivatives we are talking about, right? So let's review some derivatives first and how to use those different rules, the skills. Then we'll do some apps. So for the first one, so since we are learning what? Derivatives. So if we do the first one, if f of x is x squared, okay, we want to find it with what? Using rules. So how do we do derivative? We just take a derivatives. This is a simple one, right? We just use what? Power rule. The simple variable with the power rule. By moving the power to the coefficient, then drop one level. So that would be your answer, right? We say, also, the reason of this rule exists, the tool, then it was built this way, okay? Using what? The concept of limits. Derivative was defined and given this way. So later on we don't do it anymore, but at least we still wanted to do it once on your exam from the original idea where and how we get the rule, okay? So we do it one more time. So f prime of x is this one, right? So now your f of x is what? X squared, right? So that's what we have. So f is saying whatever you give to me, I square you, right? So this is a given, so you should have what? This is given, so we should have this square, right? Then minus, this is x, so it's x squared of h, right? From the definition, that's how it comes to being, right? So you simplify that, multiply them out. So that would be 2xh plus h squared, right? Then since h approach to 0, you cannot plug in. When you cannot plug in, what do we need to do? We need to simplify it first, right? So this cancel out, so we have this one, right? Can we plug in now? Yes, because it will not cause any, denominator become 0, right? So that would be 2x. Do we have same answer? Yes, definitely. Right? Then we will do some more practice on the derivatives. So just using the rules, we have what? Product rule, quotient rule, and chain rule. Mainly it's the chain rule you need to watch out. So if f of x equals 4x squared minus 3x plus 1 to the cube, right? So we have a power, so that would be power rule, right? But inside it's not just x, so we need to use chain rule as well, right? So if we do d dx for this one. So instead of a power rule, we use what? Generalized power rule. That means you need to apply the chain rule as well. So for the power rule, you move the coefficient out the front, then drop one level, becomes 2. Then you follow the chain rule for the inside, right? So this one will be the same, right? This one derivative, then individual one, you use what? Sum and difference rule. Then individual one, you have what? Power. So you move power outside, drop one level, and 3x would be 3. Constant, you use constant rule, would be 0, right? So that's how we do with what? Generalized chain rule or generalized power rule. Next one, your f of x is x plus 1 over x minus 1. It's a quotient, right? So if it's a quotient, what do we need to do? We use quotient rule. What is a quotient rule? When you take a derivative, you do the denominator square for the denominator. The top one will be what? You take a derivative for the numerator times the denominator, right? Minus the derivative of what? The denominator times the numerator, right? Then for this one, we simplify. Derivative of x plus 1. So derivative of x is what? 1. Derivative of 1 is 0, right? 1 plus 0 is 1. So you times this. Same thing here. Derivative of x minus 1 would be 1. And times what? X plus 1. Then you simplify them. You multiply them out and combine like terms. That would be what? You will have negative 2 on the top. Bottom is your x minus 1 squared. Right? So we are practicing the derivatives using different tools, right? So either generalized what? Power rule or quotient rule, and one more for the quotient rule for the next one. x5 plus 1, 5th power, right? So we are going to take a derivative for this one. Still a quotient, right? But seems more complicated for inside. Besides x, you have x 5th. So we do the same thing. So for the quotient rule, so you do what? The denominator take a square, then the numerator will be what? You take the derivative of the numerator, right, times the denominator minus the derivative of the denominator times the numerator, right? Then we simplify. So that would be x 5th minus 1 squared on the bottom. Then this one, the top, take a derivative, same thing Because here, power rule. That would be what? 5x to the 4th power. Right? Then derivative of 1 would be what? 0. So we have this. Right? Same thing here. Derivative of that would be what? 5x to the 4th power times what? X fifth plus 1. Is that right? Right? So that would be 5x to the 9th. Cancel out. So you have minus 5x to the 4th minus what? 5x to the 4th. So we will have negative 10x to the 4th over x fifth minus 1 to the square. Is that correct? Right? So we are practicing the derivatives with different rules. And also we went back for the first problem. We used the original idea of the derivatives, which is the limit. And we practiced that one as well. So let's see next one. F of x equals x fourth multiply a radical. So you can see that's multiplication. Then you will use what? Product rule, right? But we don't do the radicals. We use what? The power. So radical square root means what? 1/2 power, right? Then we do the derivative of this one. X fourth times x squared, right? Then we say we use power property. Power property is what? You take a derivative of the first one, multiply the second one, right? Plus the derivative of the second one, right? Multiply the first one, right? Then we do it individually. So this one will be what? 4x cubed, and this one remains, right? Then plus, then for this one, take a look. It's a power, but inside the power, the base is not only x. It has what? More complicated situation. Then we have to follow the chain reaction, right? So you have to do more. So you take a power out by power rule, right? So we use, then drop one level, and you do more for the inside. So we use what? Generalized power rule. Then multiply this. So far so good, right? So this one will be x cubed times this 1/2 power plus, right? So this is a 1/2 x squared plus 1 negative 1/2. Then take a derivative. This is a simple one, so you just do the power property, power rule, right? Times x4. Is that correct? So, are we good? So this cancel out, right? So what do we have? 4x cubed x squared plus 1/2 plus what? X squared plus 1. Oh, that's x fifth. So usually we put it in the front. So x squared plus 1 to the negative half. Are we good? Okay, let's see some apps on your page 2. Marginal profits. Okay, it says your research shows the profit function is this way. They have a model. It's a P of X equals this polynomial. Okay, in dollars. From renting out X snowboard at your ski snowboard rental shop. First, it asks you to find the marginal profit function. And we know marginal means what? We need to do what? It means to find the derivative. So for the marginal profit function would be the derivative of the profit function, right? So we do the derivative from P of X, that would be times 2, drop 1 level. So that will be your profit, marginal profit function, right? Then it also says find the marginal profit when X equals 25 and interpret your answer. So this original function, the model, it tells you what? The total profit when you rented out so many snowboard, right? If X is 1, then P of 1 means what? The profit from renting out how many snowboard? 1, right? Then if X is 2 means what? Profit from renting 2 snowboards, right? That's what it means from this model. So let's see. It wants us to find P of 25, then marginal profit at this point of time when 25 rented out, 25 snowboards rented out. So we plug in, then what do we have? Plus 25, plug in the marginal profit function, right? So it says it's 23.5. What does that mean? Marginal means what? When you rent out 1 more snowboard after you renting out the 25 of them at that margin point of time, right? So it means after renting out 25 of them, right? 25 snowboards, the profit will what? Increase. Marginal means the change at a time, right? If it's positive, will be increase. If negative, will be what? Decrease. We increase about how much? That's the number, 23.50, right? To rent it out 1 more snowboard. That's what it's saying, right? So if we do analysis, let's see what does that mean, okay? So interpret the P prime 25, it means when you rent 1 more snowboard at a time, you rented out 25 of them already, then your profit will increase what? About 23.50, right? So if we analyze the original profit function, right? So it says what? The profit function is what? Total profit on renting out, because we are doing the 25. So let's do 25. So we plug in 25 for the model. Then see what will happen. P25, right? That means 0.0 x is 25 to the square plus 25 times 25 minus 40. So that will be, you do your number, that will be 566.25, right? Then when it's 26, you plug in 26, then you will have, do the same thing here, then you will have 586.27. That means if you rented out 25 of snowboards, and you will make such a profit, $566 some dollars. When you rented out 26 of them, you will make such profit, $589.27. So what's the difference between these two? It means you add what? A profit of what? $23.47. That means after you rented out 25 snowboards, if you rent one more, according to this model, you should make $23.47 more profit, right? That means what? Marginal. Is that pretty close to what we have by doing what? The derivative. That's what a derivative means at this time, right? So we review the what? The marginal profit function and the derivative and its meaning. So we review the what? The rules, right? Derivatives and the applications, how to use derivatives. Now let's go back to review those things called limits, continuity, and differentiation. Okay, let's do the limits first. Limit x approach to 4, then find the limits of the square root of this thing, right? So how do we find the limits? So we just look if we can plug in the number, then we just do that, right? So we can plug in the number directly. So we just do it, okay? So you just plug in, becomes 4 squared plus 4 plus 5, square root 25 is 5. So the way to do the limits is to plug in, if we can do it, okay? Then if we have this one, find the limit when x approach to -1, so 3x squared minus 3x, 2x squared plus 2x. So first we check if we can plug in directly. So when you do -1 squared, it's 1 times 2 is 2, minus 2 is 0. So make a denominator 0. Then we cannot do it. So we cannot plug in directly, right? Why? Since you will make the denominator equals what? 0 if x is negative 1, right? So we cannot do it. So what do we need to do? So we need to simplify first, see if we can plug in that way, right? So we do that. And when we do it, it will look like this. We simplify. Then how do we simplify a fraction? Rational expression or rational function, right? That's what you learn in 152B class. So that's x minus 1. Is that right? Oh, this is a cube. So that's a square, right? And here you take out 2x, x plus 1, right? At this time, you still cannot plug in negative 1. Okay, then see we can simplify more. So on the top, you do the factoring, right? A squared minus b squared equals what? A plus b, a minus b, right? Factoring a binomial, the difference of two squares. So we do that, we cancel out. So what do we have? We have a limit, x approach to negative 1. So you have 3x minus 1 and 2. Can we plug in now? Yes. So you plug in, then you can forget about limit, the symbol for limit, because you already plug in. You already found the limit, right? So that would be 3 negative 1 minus 1 and 2. That would be what? Negative 3. Is that right? So that would be your limit for this problem. Let's look at the next one. Okay, so let's find the limit of what? When h approaches to 0, 2x squared, h minus hx squared over h. So can we plug in h to the denominator? So same reason apply here, right? So what do we do? So we simplify first. So that would be, so you do your factoring, x and h. You can take out, right? So that would be 2x minus h. Is that right? So you cancel out. Then we have what? Limit. H is gone. So you have x times 2x minus h, right? Now we check if we can plug in or not. If we cannot, that means there are some issues. Okay, so you may not be able to find the limit, but at this time we can. So plugging h is 0, so you end up what? 2x squared. Then that would be your answer for this problem. Good? So we are reviewing the limits and continuity and differentiation, right? So all those three concepts are related to each other. And for us, we don't really care that much for our purpose of this class. But those are hearts and soul of the calculus, okay? So we just go through it for the first exam. And later on, we don't use this part anymore. So limits, we use the limits to define what? Derivatives. That's what we have been doing, right? And at the same time, continuous of the function, you will have some kind of direct connections with derivatives as well. Okay, so we look at this graph. That means what? Y value is your f of x from x. At the time of 0, 1, then you cause the y values happen, right? So for this one, then we analyze for different points and what kind of limits they have, and are they continuous or not. Then we can tell, do we have derivatives or not? Whether or not we can use these skills to solve problems. It has to be meaningful for the derivative, right? For us to use. So let's see, let's do some limits first. So for limits for the x to the negative 2 minus of f of x, what does it mean? What do we need to do? Okay, so what is this one is saying? If my x is negative 2, which is here, right? Which is there, and its approach from the left-hand side. Its approach from the left-hand side, actually, it's like that. Approach from here. So, what's my limit of f of x? So, what's my f of x is bounded by. So from here, the bounded by approach to where is 2, right? That means from left-hand side of negative 2, this negative means what? From left-hand side, from, right? From the left-hand side of the x is negative 2. What happened? What's your limitation on the y value, right? So your y value is what? Is bounded by and is what? Actually is limited to, right? Limited to, or we can say y value is approaches to what? 2. Is that right? That's what I mean. That's what the limit means, right? So if we ask you if I'm going to do x negative 1 positive there, what does that mean? It means at the negative 1, I'm going to approach my x from what? Right-hand side. I'm going to approach here from right-hand side, right? From right-hand side of negative 1, what's your y value is limited to, or the y value approach to where? That's the point. Is that right? Oh, not the negative 1. X is negative 1, but the y value is what? 0. Right? We are talking about limitation of the y value. F of x means what? Y value. Is that right? Okay. Let's look at the next one. Limit x approach to 0 equal f of x. So this one, I didn't say what? Approach from right hand side or left hand side. That means I'm going to approach it from both sides, right? That means my x is approaching to the both sides. Right? What's my y value? It's limited to which one? Right? So either from here or from there for the x, right? For the x. What do you think your y value will be bounded by? You can tell, doesn't matter from right or from the left, y value is bounded by 1, right? What it's saying is from the left and from the right of what? X is 0, right? What happened to y value? If two sides are different, then you don't have a limit. They have to bound by one value. So the both side, the y values, well, are limited to or approach to what? 1, right? So both sides have same y values we are talking about. If they don't have same y values, that means they are not bounded by, they are not limited to, then we will not have limits, right? Got an idea about limits? How we find the limits physically, right? By looking at the things. So, looking at the y values. Then if we say limit for x approach to 1, what's your y value? Do we have a 1? To find it, x approach to the right hand side and left hand side of 1. So approach to here, approach to here. Is the y value bounded by? What's the y value at this point of time when x is 1? Is that 0? So for same reasons as this, right? The same reason as that, approach to x is 1, right? From both sides, the y value is limited by same number, right? So if it's known limits, then you don't have derivatives, right? Okay, if the y value is not bounded by certain things, so if we do this one, x is approaching 3, what's your f of x? So at 3, at this point of time, from left hand side would be what? All the way here, negative infinity, right? From right hand side would be what? Positive infinity. Besides, they are not the same numbers, right? Also, they don't even have exact numbers. That means what? They don't exist. Okay? So this one, from the left hand side of x is 3, what happened to the y value? Y value is what? Goes to left hand side, goes to negative infinity. Then from the right hand side of the value, the x3 at the point of time, then y value is approached to positive infinity, right? They have different what? Y values. Besides, they have different y values, and they are positive and negative. That means you don't have exact number, you don't have a limit, right? You don't have a limit to bound the y value, so you don't have a limit at the time. Okay, right? So that's the concepts of limit we are talking about, which will apply to what? For finding the derivatives already. Okay, then let's talk about continuity, whether or not they are continuous. So at what point and the function is not continuous? Is this a function? Of course, you use a vertical line test, right? And at what point of time it's not continuous? Not continuous means what? It will not continue, right? It has been interrupted. So at this point of time, you can tell at this time x is what? -1. That means you have jump or you have holes, right? So at -1 and at what? 0. But here you have corners, right? But it continued. It continued here and continue and move on. And at what else? 2. At these 2, they didn't continue, right? And at this point, it didn't continue, right? Next one, and which point they are not differentiable. Not differentiable right? Not differentiable means what? Means there is no derivatives. Then we cannot use our skills to solve the problem. If the function is not differentiable, then we cannot find the derivatives. Of course, we cannot what? Apply it, right? Cannot apply the tools. So it means what? It means at those points, right? And we cannot find the derivatives. Okay, so what kind of things we can find the derivatives, then we call it what? Differentiable. It has to be what? To be able for us to find the derivatives. It means what? If the derivatives exist, right? It will be what? Differentiable at x. Okay, then it means what? Then it has to be certain ways. Okay, it has to be, one thing is what? The graph, the function has to be continuous. Okay, and it has to be what? No corners. Right? No corners means what? You don't have those sharp corners. It's a smooth way to carry over. Then continuous means what? You cannot have jumps, right? You cannot have what? Holes. Otherwise, it will not be continuous. This is one of the properties for the derivatives. Okay, if it's you have derivatives, you have to the graph has to be continuous. Okay, at that point of time. So that's the criteria for finding the derivatives, and same thing to determine if it is or not can be, differentiable. Okay, so at what point, to answer the question, at what point of time we don't have derivatives? So let's look at, how about from left to right? So -2, right? So -2 is what? A corner, right? So you cannot. So then after that, we have what? -1, it jumped, not continuous. Right here, you jumped and a hole, so not continuous. So those two are what? Not continuous. One is what? Jumped. And one has what? A hole, right? Then next point, that's 0. And 1 is what? A corner, right? And 2 is what? Not continuous, right? Jump. And 3 is what? Same thing, you jumped, right? Both are not continuous. And we have a jump in there. Got an idea? Okay, so this part is not critical for our class, but at least we'll have to do it once for the sake of calculus. Are we good? So these sections will be on your exam 1. So that's for review 1.